All right, I'm back with problem 3, still talking about related rates. And in this particular problem, it says that we are going to talk about cars. Okay, so a road perpendicular to a highway, there's that bell, leads to a farmhouse located 2 kilometers away. Okay, in other words, the farmhouse is 2 kilometers away from the highway. A car travels past the farmhouse at a speed, so that would be my rate, of 80 kilometers per hour. Well, I know speed is a rate because it's comparing 2 units, right? Kilometers per hour. How fast is the distance? I'm going to do this in a different color, sorry. How fast is the distance between the car and the farmhouse increasing when the car is 6 kilometers past the intersection of the highway and the road? I don't know about you, but I can't keep track of the things that I'm supposed to be keeping track of here, right? Like, in other words, I just need to draw a picture. And so I'm going to draw that picture. And I'm going to start by drawing my house. Here's my house. And I'm no artist, okay? And it says that a road is perpendicular. A road perpendicular to a highway leads to a farmhouse. Okay, so here's the road. It's perpendicular to the highway. That means I have this 90-degree angle. And it says a road perpendicular to a highway leads to a farmhouse located 2 kilometers away. In other words, this distance here is 2 kilometers. Okay, the house or the farmhouse is 2 kilometers away from the highway. That road length is 2 kilometers. Okay. All right, a car travels past the farmhouse at a speed of 80 kilometers per hour. So here's my car. Okay, there's my car. And its speed, which means the rate, okay, my rate of my car is 80 kilometers per hour. How fast is the distance between the car and the farmhouse increasing when the car is 6 kilometers past the intersection of the highway? Okay, what that means is, I'll translate for you. I want to know how fast this length, this distance here, is increasing, right? As my car is driving this direction away from the farmhouse, it's getting further and further away from the farmhouse. And I want to know at what rate is the distance between the car and the farmhouse increasing. So I know if it's increasing, it should be a positive rate. And it's saying at the moment that the car is 6 kilometers past that intersection. Okay. Well, I don't know about you, but this to me looks like a right triangle. And when I'm dealing with distances in right triangles, I'm thinking about the Pythagorean Theorem. Okay. I know a fixed value. Okay. I know that this length right here, this 2 kilometers, is a fixed value. But I don't know the values of the hypotenuse of this triangle or the lower leg of this triangle. I know I'm trying to solve when the lower leg of the triangle is 6, but it's not a fixed number. That lower leg is a changing distance. As the car moves, that lower leg's length is changing. So that's not fixed, okay? And that matters, the idea between this fixed distance versus a non-fixed distance. Okay, so let's just come up with some variables. I'm going to call this variable x. You could call it C for car, whatever you want, okay? And I'm going to call this hypotenuse, I'm going to call it D for distance. That's what I'm looking for, is the rate at which that D distance is changing. And again, I like to come up with my variables. It's talking about a moment. It says, where does it say a moment? Car travels past the farmhouse. It talks about a speed of 80 kilometers per hour. It doesn't say a moment. My apologies, but it does give us the unit kilometers per hour, which means per hour. Time is my independent variable. Of course, this is happening over a period of time, right? And so if this is happening over a period of time, time is my independent variable. Okay, we said that x, or I'll say x of t, is going to be the distance of car to the driveway, or to the road, I should say. That's this lower distance, that lower leg, and d of t, that hypotenuse. Okay, this is going to be the distance. Just need to move this a little bit. This is going to be the distance of car to the farmhouse. So you got to keep those two separated in your mind, what they represent, which is why I like to draw a picture. Because when I draw a picture, I know what variable goes with which length, the hypotenuse or the lower leg. Okay. Now, I said when I'm dealing with a right triangle and I'm dealing with distances or lengths of the sides of that right triangle, I'm thinking about Pythagorean theorem. Okay, Pythagorean theorem says a squared plus b squared equals c squared, right? Pythagorean theorem, a squared plus b squared equals c squared. And really what that means is that the leg squared plus another leg squared is equal to the hypotenuse squared. And the reason why I wrote it as 2 squared plus x squared equals d squared is because I was using the variables that I picked for my problem. 2 is a fixed number. That number does not change. X is the variable representing the distance away the car is from the road, and d is the variable representing the hypotenuse, the distance from the farmhouse. Before I deal with this 6 kilometers per hour or the speed of 80 kilometers, I need to take the derivative. This is saying how fast is a rate or a speed? Is the distance between the car and the farmhouse increasing? In other words, I need to find a derivative. Well, I can clean this up before I do that, right? 2 squared is 4. So I have 4 plus x squared equals d squared. And I really should have these in terms of t, right? Like this is really going to be x, doesn't want to erase there. This is really going to be x of t squared equals d of t squared when we're thinking about these functions, okay? But if it's easier to think about it just as x and d and it's all related to time, that's fine as well. I'm taking the derivative of each of these terms with respect to t, right? Take the derivative with respect to t. Take the derivative with respect to t. Take the derivative with respect to t. The derivative of the constant 4 is 0 plus, well, this function x, x of t, I'm going to take the derivative of that. That's 2x. Okay, but x is not the independent variable. T is actually the independent variable. So I've got to multiply by the rate at which x is changing, dx dt. This is implicit differentiation. Again, my independent variable is t. I'm asking you to find the derivative of x squared. The derivative of x squared is 2x. X is not the independent variable in this case, so I have to multiply by the derivative of the x function with respect to t. Equals, same idea. I'm going to take the derivative of d with respect to t. That's 2d, although d is not the independent variable, so I need to multiply by, this is going to look weird, the derivative of the d function with respect to d. Or you guys could write this as d prime. You could have 2x times x prime equals 2d times d prime. Doesn't matter which way you want to write it. I just like to write it in terms of t because it's a reminder that t is the independent variable. All right, I should know some things, right? I should know some information, and the 0 isn't going to matter, but the I know the x. It says that at how fast is the distance between the car and the farmhouse increasing when the car is 6 kilometers past the intersection? So that x is 6. I don't put the 6 in to begin with before taking the derivative. 6 is not fixed. 6 is variable. I'm looking at the moment when the car is 6 kilometers away, so I wait until after I take the derivative. I also know the rate at which that length is changing. That was this right here. The rate at which the car is traveling or that distance is changing is 80. Okay. My job is to figure out what d prime is, the rate at which the distance is changing. And so I don't know what d prime is. That's my goal, to figure that out. But as of right now, it feels like I also don't know what d is. However, I do have this handy dandy Pythagorean theorem that I could use to help me figure that out, right? And so it's like off to the side, I'm going to say, okay, 2 squared plus x squared. Well, at this particular moment, I know that I'm looking at that x value of being 6. So 6 squared equals d squared. Okay. Well, that gives me 4 plus 6, which is 4 plus 36, which is 40. If I take the square root of both sides, I get square root of 40 equals d. Yeah, it should be plus or minus, but I'm not going to have a negative length. Okay, I'm just not. And so that means that d is square root of 40. So again, I had to do this extra step. I had to use my Pythagorean theorem in order to determine what that distance d was, knowing that the car is 6 kilometers away. Now I can do a little solving. Okay. So let's see. What do I have here? I have 2 times 6 times 80. I don't know. What's that give me? 960. Divided by 2 square root of 40 is equal to d prime. And I can clean that up a little bit. 960 divided by 2 is 480 divided by square root of 40 equals d. Now, d prime. Now, you could technically leave it like this. In calculus, you don't have to rationalize. You don't have to simplify the square root. But just for fun, you might see this as, well, square root of 40. I could factor a 4 out. Square root of 4 is 2, so it gives me 2 square root of 10. Right? I could leave it like this. I could say that this is 240 divided by square root of 10. I have options, okay? And then finally, I should put a label on this. This is going to be kilometers per hour. Okay, it's still a length. It's not an area, so I don't need squared. It's still a length or a distance. Kilometers per hour is the rate at which that is changing. Okay, on to the next video.